Hi, my name is Naomi. I'm a software engineer at MavenLink. We're a software company in San Francisco, and we make project management software for consulting firms. We have a pretty cool culture. We do pair programming, and yes, we are hiring. If you're interested, please come up and talk to me afterward. Currently, on my team, I'm helping to transition away from Backbone by building our first feature in React. But today, I'm here to talk to you about Webpack. Let's get started. Why are we talking about Webpack today? Well, it's a tool for web developers that is, one, very popular, and two, not very well explained, as far as I can tell. How popular? This data is from NPM, the JavaScript package manager, and it's tracking downloads per week for Webpack and some similar tools, Gulp and Grunt and Browserify. Webpack is the red line, and we're tracking from 2014 to 2017. So as you can see, Webpack has gotten pretty popular. And if you're wondering what that giant dip is all the way at the end, that's the winter holidays. Nobody codes on the holidays. So the first stable version of Webpack was released in January of 2014. And as you can see, since then, it's gotten more and more popular, and now it has over 1 million downloads a week. That means that there are a lot of people using Webpack, and as far as I know, a lot of people who are confused about how to use Webpack. So have any of you used Webpack before? Awesome, cool, I'm glad to see that. Great. So how did I learn Webpack? Well, I used it for a couple of side projects because I wanted to use React, and when I learned it, I thought that its documentation and its API were really confusing. It felt like pretty much all I was doing was copy-pasting from Stack Overflow into my config file until things worked, and I had no idea why. Have any of you guys done the same thing? Yeah, okay, good, I'm glad. I thought it was really confusing, and I sort of put it away, and I was like, wow, it's cool, it seems like it can do a lot of things, but I'm gonna forget about it for now. But then my company, MavenLink, started using Webpack to compile its assets when we did the switch from Backbone to React. And suddenly I had to figure out what was going on. And I realized that learning how to use a tool is a lot harder when you don't know how it works. So I started trying to figure out, what's Webpack doing under the hood? And I found a ton of stuff on how to set up my config file, but not really very much on what it was actually doing. So I started doing some research, and today I want to share with you what I've learned. And I want to do this because I think that we're all better and happier developers when we understand our tools. So the idea here is going to be to demystify what Webpack is doing when it creates an asset, because that's going to make it easier for you to understand what's going on when you're debugging through a Webpack asset or trying to figure out why a build failed. And it's going to lay the foundation for being able to understand all of the fancy things that Webpack can do. So today, we are going to answer 3 questions. What is Webpack? What problems does it solve? And how does it work? Let's start with what it is. So as Webpack describes itself, it is a module bundler that takes modules with dependencies and emits static assets representing those modules. When I first heard that, I had no idea what any of that meant. So the way that I like to think of it is that Webpack takes stuff that is nice for you to write, and it turns it into stuff that's nice for your browser to read. Let's talk about what that means. So easy for you to write means that it's easy for humans to read, right? We have pretty formatting, we have readable variable names, our code is separated into multiple files so that we can separate it logically. And it might not even be in a language that the browser can understand, right? ES6, also known as ES 2015, is the new specification for JavaScript, but browsers haven't implemented a lot of the new features yet. Some people don't even want to write in JavaScript. They want to use a language that transpiles to JavaScript, like CoffeeScript or TypeScript or ClojureScript. But what's nice for your browser to read is old school JavaScript, right? ES5, the standard stuff. We want to make fewer requests, which is great for bad internet connections, and we want to have smaller responses, right? We don't need white space or pretty variable names. The browsers don't care about that, only we do. And as you'll be able to see, Webpack is going to help us do those transformations. Cool, so what problems does Webpack solve? The first one is namespacing, right? In JavaScript, variables that are declared outside of functions are global, and that means that it can be really easy for our global namespace to get cluttered, and that means it can be difficult to keep a good separation of concerns. The second problem is that files need a lot of work before they can go to the client, right? We have to do transpiling, we have to uglify our code, we have to minify our code. There's lots of stuff that we want to do to change it so that by the time it gets to the browser, it's in the state that we want. And the third problem is how to send the code to the browser efficiently, right? We have a ton of files, but if we had to put in one script tag per file that we have, like that would be insane. I mean, first of all, it's slow, and second of all, it's really hard to manage our order dependency. We'd have to make sure that scripts are requested in the right order, and that can be really difficult, so it'd be great if we didn't have to do that. I want to note, obviously, Webpack did not solve these problems first. I'm not getting up here and saying, like, Webpack does something that no one else has done before. Gulp and Grunt and Browserify, or some combination of those, have been amazing. My company is a Rails app on the back end, and we use the asset pipeline to do this, and that worked great when we had it. I'm not bashing those. But Webpack kind of does it all at once. I think it does it a little more elegantly than some of the other ones, and it turns out that its implementation is actually really simple under the hood. So simple that an entire Webpack built asset will be able to fit on one slide later, as you'll see, and I think that's really cool. Okay, so the fun stuff. How does Webpack actually work? How does it do its magic? Before I want to tell you how it works, I want to talk about how I thought it worked when I was first starting out. I thought we had a bunch of files, right? We have these little blocks, and we had dependencies which we're going to represent with these little bars at the tops of our files. So our orange file depends on our yellow file, and our purple file depends on our orange and green files, and our yellow file depends on our green file, and so on. And I thought, and as far as I knew, the Webpack, wizard just kind of smushed them all together into a single plain JavaScript file that we could send to the browser. And if you had asked me, how do you think it works? I would have said, well, it's probably doing all of these crazy calculations to figure out what order the files should go in based on their dependencies, and then it's concatenating them all together. That's not crazy, right? We have other tools that do that. Grunt and Gulp do something pretty similar. It turns out that is not how Webpack works at all. So if you are thinking like, that's what I used to do, this is probably what this does, just forget about it. So now, so that we can talk about how it actually works. Cool. So to start out, Webpack takes the path to a single starting file. If you've used Webpack at all, that's going to be your entry file. That's what it's called. And it's going to be the top of your app, the thing that's going to kick everything else off. And based on that starting file, Webpack is going to make an asset for you in 4 steps. First, it's going to find dependent files. It's going to apply loaders. It's going to implement our module system, and then it's going to put it all together and make the final asset. And if you don't know what those mean yet, that's cool. We're going to go through them right now. So let's talk about finding dependent files. So the first thing Webpack is going to do is it's going to make an array that's going to keep track of all of our dependent files. We're going to start at our entry file, and we're going to look for dependency declarations. Those are going to be requires or imports. Webpack can support multiple kinds of module systems, AMD, CommonJS, ES6, and we'll talk about that a bit later. But for now, all you have to know is that it just looks for those dependency declarations. And then for each dependency, we have to validate the path. We have to make sure it leads to an actual file or an actual node module that exists. You didn't mistype the path, and you've actually installed the module, so it's there. And if it leads to a valid path, cool, we're going to add that file to our array. And we are going to remember this array for later because it's going to be really important. The next thing we're going to do is apply our loaders. And a loader is something that you've probably read about. There are lots of loaders for lots of different things, but at their heart, they're really simple. A loader is just a function that takes in source code, makes changes, and returns the new code. That's it. This is the JSON loader. It's available on NPM, and as you can see, all it does is take in a source, and it stringifies the code into JSON and returns it. This is a loader that people use. It's super simple. More about loaders. Where do they come from? They're on NPM. Anybody can write them. Webpack itself uses a lot of internal loaders and has published a bunch of external loaders that you can use. You can write one to do whatever you want. How are they used? Well, we tell Webpack which loaders to apply in our config file, and they can be applied selectively with regex. So my company used to work in Backbone, and so we also worked in CoffeeScript, and so we have a ton of CoffeeScript files and a ton of plain JavaScript files. We don't want to transpile our plain JavaScript files into plain JavaScript again, right? That'd be a waste of time. So we say only apply the CoffeeScript loader to the files that end in .coffee. And you can chain loaders together sort of in whatever order that you want to get the result that you need. And so all of the things that we talked about before that we want to do, our transpiling, our uglifying, our minification, all of those things happen through loaders. You can also add polyfills through loaders. You can do whatever you want. You could say, like, if anyone uses eval, throw in a giant ASCII art that says, like, no, don't do that, like, go revert that commit. You can do anything. And then Webpack is going to implement the module system. And to talk about that, we're going to take a little detour and talk about CommonJS. Webpack supports multiple module systems. They all kind of work the same way under the hood, but we're going to use CommonJS to get the idea of it. The principles are going to be the same, but the syntax will differ across different ones. So, what is CommonJS? CommonJS is a system of writing JavaScript that allows files to declare dependencies on each other by importing and exporting modules from those files. In this system, we have one file per module, and if I say file or module, I'm talking about the same kind of thing. So we import modules by requiring them by name or by path, and we export modules by assigning them to a variable called module.exports. And we don't have to define module.exports in our code, we just assume that it's available to us, and we attach it. The important thing to understand is that CommonJS is a standard. It's not a library. You don't import CommonJS code. It's a set of rules that says, like, hey, if you write your code this way, things will work how you expect. So we write our code following the CommonJS system, and Webpack makes that system work by implementing the standard. Cool. So how does it actually do that implementation? Let's start out with an example. Can you guys read the code on there? Yeah? Cool. Good. Is it hard? It's hard to read the screen. I think we had an issue with the lights. We can't turn these lights down unless we turn all of the lights down. So I think we have to leave them on for now. Sorry. Let's start out with an example where we have two modules. We have Square.js and Hypotenuse.js. Hypotenuse is going to be our entry file, and it depends on the module Square. And so in order to implement our module system, Webpack has to do two things to these files. First of all, it has to wrap each file in a function. And that function is going to take in two arguments, module, and a function called Webpack Require that Webpack defines and that we'll talk about later. Then, if you remember that array, we note that hypotenuse is going to be at index 0. And it's going to be at index 0 because it's our entry file, and our entry file is always going to be the module at the first index in the array. The other ones can be in sort of whatever order we want. And so Square is going to be in index 1. And Webpack looks at all of the require statements, and it replaces them. Instead of saying require the path, it's going to replace it with Webpack Require, and it's going to invoke it with the index of where that module is in our array. So you can see here that Square now reads var Square equals Webpack Require 1 because Square is at our first index. Cool. As a little bonus, you might have noticed that replacing require statements with other require statements kind of sounds like taking source code, making changes, and returning new code. And you might have noticed that wrapping each file in a function kind of sounds like taking source code, making changes, and returning new code. And if you're thinking like those processes sound like they could be loaders, you are absolutely correct. Webpack implements the module system just by applying its own internal loaders to all of the files. And so it turns out that implementing our module system isn't really a separate step from applying loaders. It's kind of a subset. Webpack has to apply both the user-specified loaders and then its own internal loaders. Okay, so let's put this all together and talk about how Webpack actually makes the final asset that you can send to your browser. So what does our final asset need? It has to have all of our code, right? It needs to have our entry file and all of its dependencies. The idea is that we should have to make one request. You can do sort of more complicated async requests, but we're not going to talk about any of those fancy features today. We're going to talk about the most basic application of Webpack we've got. It has to define the Webpack Require function that we talked about, and it has to put it all together. So we are going to write a Webpack asset right now together on the screen. Can you guys see that even with the light? Okay, cool. So we are going to define a function, and it's going to take in a module array as its argument. We're going to wrap it in parentheses, and we are going to immediately invoke that function with that array of modules that we've been talking about. If you're not familiar with this pattern, it's called an IFI, or an immediately invoked function expression, and it just means that the function gets used immediately after it's defined. So we'll pass in our array with our entry module and then all of its dependencies. Inside of that function, we have to define Webpack Require. And this is going to be kind of the crux of it all, the thing that ties it all together. This function is going to be the thing that allows modules to talk to each other. So when a module says like, hey, I need the green module in order to finish up my work, Webpack Require is going to say, hey, I know where the green module is. Let me go get its export for you, and I will give it to you so that you can get its code. So inside the Webpack Require function, we actually have to create the module that we're talking about, and it's going to have a key called exports that is also an empty object. We're going to do this every time we want to get a module's export from a file, so this module object will only have the exports from a single file. Next, we're going to grab the file that we need. We'll know where it is because the argument to Webpack Require is the index of the module that we have. And if you remember, we've wrapped all of our files in a function, so we can actually execute the file now and pass in the module that we just created and a reference to Webpack Require itself. So that is where we get access to module that we just assume is available to us when we write JavaScript. And when we invoke the function, it's going to execute all of the code in that file. And when that happens, right, we'll get any side effects like appending to the DOM or logging to the console, whatever you want, that's going to happen. But what is also going to happen is that the file might attach stuff to module.exports. And when they do that, when it's finished executing, inside of Webpack Require, we'll still have access to that exports object, and we can grab it and return module.exports to the thing that called Webpack Require in the first place, which is what we do. So once we've defined Webpack Require, we're going to kick off the whole thing by invoking Webpack Require with 0, because that's going to be our entry file, our first one, and that will set off the whole chain of events that will lead to all of our code being executed. So some of you might be like, that seems super inefficient, Naomi. Like, what if two modules import the same module? Are we going to execute the code of every file every time over and over and over again? That's a great question. Webpack is smart enough to optimize for this, and it's actually going to cache the modules so that we only have to evaluate them once. So we make a cache object inside of our main function, and if we've already requested the file before, we're going to do an early return and just give you back the exports object. If we haven't seen it before, we'll evaluate it, get its export, and save it in our cache for the next time it's requested. And that's it. That's the whole thing all on one slide, like I said, which I think is pretty cool. But some of you guys might be like, that is a lot of text in front of me. Like, can I please see an example of this? Yes. You can. We're going to walk through an example and then walk through the code, pretending that we are executing the code like the browser. So we're going to work with an example repo of 3 files. Our first file is our old friend square.js. It has no dependencies. It just exports a function that returns a number square. Our second file is our old friend hypotenuse.js. It depends on square, and it exports another function that returns the length of a hypotenuse given the other 2 sides. Finally, our main module, index, is going to import hypotenuse, and its whole goal in life is to log to the console the result of calling hypotenuse with 3 and 4. It's pretty simple, and index is going to be our entry file. So let's pretend that we've compiled this repo with Webpack, with index.js as our entry, and walk through the code as the browser would see it. So on the left, we're going to have the Webpack asset. This is what we get sent to the browser. And on the right, we're going to keep track of a couple things. So we're going to start out after defining Webpack Require. And you're going to see that little output bar, and we'll know that we've sort of finished our job when we see something get logged to that console. Cool. So when we invoke Webpack Require, that's going to pop us into an invocation of Webpack Require, and I'm going to keep track of some of the variables on the right. So our index is 0, and right now module.exports is just an empty object. We're going to grab the file that we need and execute the file, which is going to pop us into index.js. And we'll see that the first thing that we do in index.js is declare a variable called hypotenuse that is going to call Webpack Require again. So that's going to put us into another invocation of Webpack Require. This time we're looking to grab the export of module 1. We're going to grab the file and we're going to execute it. That's going to lead us to hypotenuse.js, where again the first thing that we do is declare a variable called square, which is going to call Webpack Require. That's going to put us into another invocation of Webpack Require, which is going to look for the export of the module at index 2. So we're going to grab the file, and we're going to execute it. And we're inside square.js, and this is the first time we haven't started off by just going off and getting another thing. We're going to actually define the function and attach it to module.exports. And once we've finished executing this file, we go back here, and we can see that our module.exports has the function that we assigned to it, and we can return that function back to hypotenuse.js, which we do here, and now Square has the function that we want. Then inside of hypotenuse.js, we define our function that gives you back the hypotenuse. We attach that to module.exports. And so back in this Webpack Require invocation, we now have access to that function, and we can return it back to index.js, and index.js now has the hypotenuse function, and cool, we logged 5 to the console. We did it. We're amazing. And Webpack is going to finish up. We got what we wanted, but Webpack, it's going to keep doing its thing. It's going to finish returning module.exports until it's done. And that's the entire execution of a Webpack asset, which I think is pretty neat. Cool. So, how did this solve the problems that we talked about earlier? Well, getting our code to the browser efficiently, we now have a single script tag for our entry file and all of its dependencies, and all of its dependencies are managed for us. We don't have to care what order they need to go in. All we have to do is declare our dependencies at the tops of our files, and Webpack will do the rest. We had the problem of global namespacing, right? Variables are now scoped to their own files because we wrap them in a function, and they only expose what they need, and they do that by putting it on the exports object. And one pretty cool side effect of this is that now we can have something sort of close to module privacy in JavaScript. We have a Rails backend, and I was pretty new to Rails when I started at my company, and I was like, I don't know what all this magic is, but that private stuff is great. Like, I want that. How do I get it? You know, before in JavaScript land, it was like I make a class, I put a method on the class, and anything that's using that class can call it, even if I want it to be internal. This is really cool. Now, if you don't want another file to use the code that you're writing, just don't export it, and it won't have it. That's pretty great, in my opinion, and it can let you write your modules as though they have APIs, as though every single module you have is like a black box, and that can lead to some really nice code separation. And the final problem that we had was that it was difficult to manage our necessary transforms, right? But now we just tell Webpack to apply the loaders we need to the files that we care about. And the browser ends up just getting JavaScript that it can read, which I think is pretty great. That's about it. Thank you guys so much for listening. Thank you to Manon and Daniel for inviting me to speak. Again, I work at Mavenlink. We're hiring. You can reach me at Twitter or GitHub or by email. I've also put up a GitHub repo that you guys can check out if you want that will walk you through a real life example so you can see for yourself what a Webpack asset looks like. Just go grab it, check it out, and just open up the asset that it creates and you'll see for yourself that it's really pretty simple. So just reach out to me and let me know what you learn. Thank you so much. Are there any questions? Yeah.
Hi. So I was wondering about if you're pulling in someone else's code via, either NPM or something like that. How does Webpack deal with the possibility that that code was built with a different module system, or the possibility that that code was already built with Webpack and is now being exported?
That's a great question. Yeah. So when we actually had a problem with this because we built our own NPM module for our own use, and we published it, and we were like, oh, this is great, but we forgot to compile it. We forgot to publish a compiled version, and we just assumed other people were using Webpack, which they were not. That was crazy. So I think most people assume that if you get something from NPM, that it will already be compiled for you, and that it will have one index, one export that you can grab, and it will already have its compiled thing. I believe that there's an option in Webpack to say like don't compile it if you've asked for it, so that other people can do it. But my understanding is that sort of the NPM contract is that I shouldn't have to compile your code if I want to use third-party stuff. Yeah. Yeah.
Hi.
Hi.
Thank you for that, and I'm sure my keyboard thanks you too. So one thing I know about Webpack that it can do is that it can figure out what components are common to your project, and it can spit out a common .js file.
Yeah.
Now that you went through that, it kind of makes sense. And my guess is that now they're probably using the caching to figure out, what's common and then splitting it out. Is that, a little bit more about that? Or?
Yeah, a little bit. So one thing that we didn't cover is that you can ask Webpack to output multiple assets. So I can give it a couple of entry files, and then it gives me a couple of assets. But if both of those assets both depend on jQuery or something, right, it would be great to not have to compile jQuery twice and have the full jQuery code in both of my assets. So if I know that they're going to be on the page at the same time, Webpack will make sort of a third module that has the modules that are common to both files, and then it will add to the code requesting that file to both of them, so that you request one and it gets you both, and then when you request the second one, it goes, okay, I already have the commons one, so I don't need to grab that again. Yeah.
Thanks.
Cool. Are there any other questions? Great. In the back. Yeah.
It's not really a question, but I just wanted to add a really great resource that I found this YouTube video I used about like a month ago. And it's like almost 2 hours long. It's called Webpack 2, a full tutorial. I think the YouTuber is Emil Oberg. and it just walks you through like a very simple example JS file, and I thought it was just like a great resource.
That's great. Thank you.
And that's it.
Cool. Yeah, another question.
So we all know that NPM modules tend to be like, let's write 50,000 small modules instead of 5 big ones. So does Webpack wrap every single one of those with a function? Because it seems like that could lead to a lot of, like, I guess, just extra code that the client is required to download.
Yeah, as far as I understand it, every module does get wrapped in a function. Usually with NPM modules, like I know, like we use Ramda in our code base, and so you can import either all of the functions in Ramda, or you can import each of them automatically. So the way Ramda structures it is it writes each function in its own file, exports that as a module, but then also exports one main one that has everything, so you can pick and choose. It does add a little bit of overhead, but it also lets you only import what you need. So if I only need one function from Ramda, I can only import that function, and then I don't clutter up my namespace with a ton of other stuff that I'm not planning to use.
Okay, thanks.
Yeah. Great, thank you so much.